the Rosalind Yallo Oration. To provide us with insights into the life and legacy of Rosalind Yallo, I am delighted to invite Professor Molly Jacob, Professor in the Department of Biochemistry at Christian Medical College, Vellore, to the stage.
Good morning, and thank you for inviting me to read this introduction to Rosalind Sussman Yallo. It is an honor and privilege to stand here before you to celebrate the remarkable achievements of Dr. Rosalind Sussman Yallo, a trailblazing scientist. Dr. Yallo was a pioneering American medical physicist whose development of the radioimmunoassay, or RIA technique, revolutionized diagnostics in endocrinology and medicine. She was born on July 19, 1921, in New York City, and exhibited an early aptitude for science. She graduated magna cum laude from Hunter College in 1941 as its first physics major. Despite the gender biases of her time, Dr. Yallo secured a teaching assistantship at the University of Illinois at Urbana-Champaign, where she was the sole woman among 400 faculty members in the College of Engineering. She was also one of the first women to earn a doctorate in physics from the University of Illinois. Returning to New York, Dr. Yallo taught physics at Hunter College, and in 1947, she began her long association with the Veterans Administration, or VA Hospital, in the Bronx. There, as she collaborated with physician Solomon A. Burson to explore medical applications of radioactive substances, their partnership led to the development of the RIA technique, a highly sensitive technique capable of measuring minute concentrations of hormones, vitamins, and enzymes in blood. The RIA technique was initially applied to study insulin levels in diabetes mellitus, but it soon transformed the ability to diagnose and understand various endocrine disorders by allowing precise measurements of previously undetectable biological substances. Notably, Yallo and Burson chose not to patent the method, facilitating its widespread adoption and benefiting countless patients worldwide. Yallo's contributions earned her numerous accolades, including the Nobel Prize in Physiology or Medicine in 1977, making her the second woman to receive this honor in the field. She also became the first female recipient of the Albert Lasker Award for Basic Medical Research in 1976. Beyond her scientific achievements, Yallo was a dedicated mentor, inspiring future generations of researchers. Her mentees include John Eng, who discovered Exendin 4, leading to the development of exenatide. Dr. Narayana Panikkar Kuchipille, a prominent endocrinologist in India, was also a mentee. She often spoke passionately about the need for perseverance, famously stating, "We must believe in ourselves, or no one else will." In honoring her legacy, may we strive to uphold the values she embodied: excellence, perseverance, and commitment to advancing human health through innovation. Let us celebrate Rosalind Sussman Yallo, not just for what she achieved, but for the example that she has set for all of us.
Thank you very much, ma'am, for your thoughtful and inspiring words. Next, it's my privilege to invite Dr. Sylvia Kehlenbrick, Director of Global Endocrinology at Brigham and Women's Hospital, part-time instructor at Harvard Medical School, and founder and director of the Diabetes in Humanitarian Crisis Program at the Harvard Humanitarian Initiative. May also invite Dr. Chittaranjan Yajnik sir and Dr. Davis Gilbert sir to be on stage. Dr. Sylvia will introduce Professor Chittaranjan Yajnik, the recipient of the Rosalind Yallo Oration.
Good morning. I've had the great pleasure of getting to know Dr. Yajnik personally over the last couple of days, so it's a special privilege for me to introduce you today. Professor Chittaranjan Yajnik, a renowned diabetologist and a true scientist from Pune, India, has played a pivotal role in advancing diabetes care and research in India. In 1987, he established the first dedicated diabetes department at King Edward Memorial Hospital, Pune, delivering exceptional care to several patients while training and mentoring a new generation of healthcare professionals, Indian and overseas, PhD students, postdocs, and scientists. Through his vision and leadership, he created a center of excellence for diabetes research. His landmark Pune maternal nutrition study unveiled the thin-fat Indian phenotype. Collaborating with Professor David Barker, he expanded the concept the thin-fat phenotype is programmed in utero and related to maternal-fetal undernutrition of proteins and micronutrients. Building on these insights, Professor Yajnik led the PRIYA trial, a pioneering adolescent intervention aimed at improving maternal nutrition to mitigate the risks of diabetes and enhance offspring neurocognition. Professor Yajnik's expertise and contributions are recognized globally. He has been instrumental in advising and collaborating on international studies, including the EFSOC and PRIDE studies in the UK, STORK2 in Norway, and various projects in the USA, Australia, and Bangladesh. With over 300 scientific publications, he has received numerous accolades, including the Helmut Maynard Award from the International Diabetes Federation, the David Barker Medal, and the March of Dimes Award. As a founding member of the International Johad Society and president of Indian Sneha, Professor Yajnik has influenced policy and research worldwide. He serves on prestigious advisory boards, including ICMR, DBT, WHO, and FIGO, and is a sought-after author for leading journals such as The Lancet, Diabetologia, and BMJ. A dedicated scientist, thinker, mentor, and visionary, Professor Yajnik's work has redefined our understanding of diabetes, the Barker hypothesis, and maternal health, leaving an enduring legacy that continues to shape global health care. We present with profound admiration the prestigious Rosalind Yallo Oration Award upon Professor Chittaranjan Yajnik on this, the 11th day of January 2025.
Thank you, Dr. Sylvia, for that excellent introduction. As a token of gratitude and respect, may I now invite Dr. Michael Boney and Dr. Dirk Lund onto stage to present the ceremonial shawls and plaques to Professor Yajnik. Thank you, Dr. Michael Boney and Dr. Dirk. Finally, it's my great honor to invite Professor Chittaranjan Yajnik to deliver the oration. We eagerly look forward to hearing his inspiring words and valuable thoughts. We welcome you, sir.
Needless to say, I'm overwhelmed by this honor. Thank you to the committee. Thank you, Nihal and all his colleagues, Meredith. And thank you for coming to listen to this talk. I've called it Life Course Evolution of Diabetes in Indians, 30 years and 3 generations in the Pune studies. Many of you know, mine is the only diabetes department in the world which has mother and baby as the logo. And that's because of the firm belief we have that mother's influence on the baby lasts not only in the intrauterine, but for the rest of the life. Many of you know about this modern Ganesh. That's our second logo. He is modern. He now works from home, and he doesn't travel on the back of the mouse. Instead, he clicks the mice, and that's a very fast journey. So intrauterine programming and rapid transition are the two foci for investigation of research in my department. I represent SNEHA, that's Society for Natal Effects on the Health of the Adults. That's the Indian Society for DOHAD, which is at least 7 years older than the International DOHAD Society, for which I am a founder member and a trustee. And I owe to MRC Life Course Epidemiology Unit, Dev Barker and his colleagues, all that I know about DOHAD. I was surprised my oration is called Rosalind Yallow. It's quite an amazing honor. And I remembered in 1982 when I went to UK for training, at one of the British Diabetic Association meeting, I was standing in the row to receive the lunch. So queuing up for lunch, and there was a lady in front of me. She was obviously American and had a very bright yellow blazer. I didn't know who she was. So I got chatting with her and I said, "Where are you from?" And she said, "From New York." And I didn't ask her name. She said, "Where are you from?" I said, "I'm from India, I'm training in England." So we sat at the table, ate the lunch together, discussed various things, and afterwards, when they invited her to give the oration, I realized it was Rosalind Yallow. So that was one of the shocking moments in my life, but that's what I think has connected me to this. So the theme for, like, say, textbooks is that diabetes and obesity, together what we call diabesity, has a genetic susceptibility, and then there are precipitating factors in later life, largely related to age and obesogenic lifestyle. That's the current model of diabetes in the textbooks. Genetics for common varieties of diabetes is polygenic and therefore not modifiable even by counseling. And we know contribution of the combined genome-wide significant loci for BMI, for example, recently shown to contribute not more than 6% of the variance. For diabetes, it may be up to 10%, but that leaves a very substantial unaccounted factors. And therefore, in clinical practice, we usually concentrate on precipitating factors. And as George Alberti said, treatment of diabetes or prevention basically relate to eating less and walking more, which is true in practice, but I think it's an end-stage intervention. Thinking about it slightly sort of deeper, we are talking of genotype to phenotype association. And from the central dogma, Watson-Crick, we know DNA contains all the information. It's transmitted to RNA, which in turn converts it into the phenotype, which is protein. And this is the model, a simplistic model, which actually shows a unidirectional flow of information. I learned as a student, before I went to medicine college, a term epigenome as part of my zoology training. And this was coined by Conrad Waddington, a famous British embryologist in 1940s. And what he said was, all the cells in the fertilized ovum have the same genetics, but from that single cell, we get the whole organism with different cells with different phenotypes. Therefore, there must be something between the genotype and the phenotype which makes that happen. And that he called as epigenome. And today, science of epigenetics has become central to understanding the disease and the mechanisms. This ultimately fed into the thinking about origin of disease in the DOHAD world. That's the developmental origins of health and disease. So we start with genome at conception, there is epigenome, and then a series of phenotypes in the life course, leading to the final phenotype of interest, which as doctors, we are interested in finding out a disorder or a disease. But a whole lot of things happen in between. And interesting to remember is that though genotype is not modifiable, the epigenotype related things have a possibility of being modified. These are three seminal studies in the field where intrauterine nutrition has been shown to affect the future risk of diabetes and obesity. The first one, which I read as a registrar in medicine in Sassoon General Hospital, in 1976, this New England Journal paper referred to the Dutch hunger winter. Children who were exposed to hunger in utero had either an increased or decreased risk of obesity as army conscripts. If they were exposed to the hunger in the first 2 trimesters, they had increased risk of obesity. And if they were exposed in the 3rd trimester, they had reduced risk of obesity. So the basic concept of window of exposure and opportunity in pregnancy was already described in this seminal study. A little later, we heard from the Pima Indian studies that here now, instead of undernutrition, gestational overnutrition of the baby in a diabetic pregnancy increased the risk of obesity and diabetes in the child right from very early age. And Norbert Frankel, based on Pedersen's observations, formed the hypothesis of mixed nutrient teratogenesis, saying that excess supply of various nutrients to the baby led to the short-term phenotype of macrosomia at birth, but increased risk of obesity and diabetes in later life. Then came David Barker's study. In 1991, he reported that in Hertfordshire, a cohort which he had set up retrospectively, lower birth weight was associated with increasing risk of diabetes and syndrome X, which we now call metabolic syndrome. Interesting to see here that it's a graded monotonic risk. It's not a cut point of low birth weight versus normal birth weight, but lower the birth weight, higher the risk. India, of course, was the place which David Barker thought was going to add significant understanding to this phenomenon, because he knew that India was world's capital of undernutrition in early age. India gives birth to largest number of low birth weight babies, and we have largest number of under 5 undernutrition. And over last 30 years, gradually we have become one of the capitals of diabetes. And this is how David Barker came, met me in February 1991, and in this 15-minute meeting completely changed the career for me. Getting diabetes at a younger age, we have now a third factor of gestational diabetes. that's higher maternal glucose in pregnancy, which itself actually increases the nutrition of the baby, so that we are now facing a double burden of malnutrition in utero for Indian babies. On one hand, undernutrition of some macronutrients and overnutrition of glucose. And therefore, I have sort of dedicated this slide to two of my gurus, David Barker and Norbert Frankel. One's talking about thrifty phenotype and fetal programming, Norbert Frankel talking about fuel-mediated teratogenesis. This led to the concepts of fetal programming and teratogenesis. Both say that there is a permanent alteration in the structure or function of the system due to a developmental adversity. And part of it is related to the inability to achieve genetic potential. Genetic and epigenetic mechanisms are there, epigenetic probably more so than the genetic, and the environmental exposures which constitute adversity are related to mother's nutrition, her metabolism, infections as we have heard today, maternal stress, various pollutants including the endocrine disruptors, and the list goes on. Interesting to know that there are windows. And over years now we have realized the most important window for fetal programming may be pre and peri-conceptional. This is even before the woman knows she is pregnant. And this is actually not included in the 1,000 days concept. Because 1,000 days start when the woman comes to the doctor or the clinic or system. So there is something even before that. This can be multi-generational and important that is preventable. This nice picture which I found on net shows DNA covered with the food we are eating. And that's the type of epigenetic imprints which are left on the periconceptional genome of the fetus, which lasts for the rest of the life. This, of course, produces phenotype, and I couldn't resist not showing this slide because in this meeting, so many people have come to me and said, "Oh, are you that YY?" And yes, I was young when I made this photograph. And now, of course, things have changed. You can see the changing phenotype here. But that picture made me sort of famous, claim to fame. Interesting things have been written at the bottom by both John and me. One of that is that John runs the marathons. And my best exercise in the morning, which now Peter knows because I see him coming from the swimming pool, and I'm running up the staircase, especially every day in my hospital when I see the lift doors closing. This is a very typical Indian exercise in the morning. The trot when you see the lift doors closing. And second thing here mentioned is that my birth weight was less than 5 pounds. So there is something, a conspiracy that I got into this field. Is that phenotype replicable in other things? Yeah, so many studies have replicated it, but this is my recent study in Assam, in the northeast part of the country. Assam is deprived over centuries for various reasons, partly because of occupation, slavery, political unrest, geographical factors. And we have described now the characteristics of Assamese young patients in a diabetes clinic. The referee was not convinced, so I did this analysis only last month. I couldn't resist showing it. And what I have done is I have compared these very thin Assamese patients, whose average BMI was 23, with participants in the NANES cohort. That's the white Caucasians in the America. And what we find is body roundness index, which is now a new substitute for, let's say, West hip ratio, is higher in the Assamese patients, that's the red line, compared to the Nains people who had an average BMI of 28. So chronically undernourished Assamese populations are centrally more round, starting at a BMI of as low as 13. So that's quite amazing. I looked at DEXA total adiposity, and again Assamese people have higher total adiposity compared to the Nains, white Caucasians, across the range of BMI in the Assamese population, again from 15 to 33. And DEXA truncal adiposity, that is fat in the center, again considerably higher in the Assamese undernourished people compared to the Nains. This is a classic phenotype, and I think thin fat phenotype is an important description of intrauterine programming. This has been described in various ways. It's quite interesting that Guardian wrote an article last year. It's called How British Colonialism Increased Diabetes in South Asians. And quite nicely they concluded it's complicated. So that's one very nice article. This figure is quite remarkable. This paper is from the WHO group of risk. And what they have traced is height in different populations of the world over last 150 years, from like say early 1800s to 1980. Europeans gained about 15 centimeters in height. Dutch gained the most, 15 centimeters. How much did Indians gain in 150 years? Any guess? 5, 7. Indians gained 0, the yellow line. So that is the degree of adversity we have faced over last few hundred years. And in some of the Indian states, there is a documented loss of height in these 150 years. So this is the chronic malnutrition we have suffered. Is it related to current increase in diabetes? Nikhil is sitting here. Nikhil is first author on this paper in Lancet, The Global Burden of Diabetes in India, Increase in Diabetes Prevalence in Different States over 50 years, 1990 to 2016. And all these red states are the ones where there is a maximum increase of diabetes prevalence. And they are more or less the so-called Bimaru states. Bimaru is a pun, includes Bihar, Madhya Pradesh, Uttar Pradesh, but Bimar in Indians is sick. These states have been sick for hundreds of years, and they are now facing the maximum increase in diabetes prevalence. So that brings me to my favorite quotation, that life can only be understood backwards. It's of course a Danish quotation from Søren Kierkegaard. Alan is here, and that to me actually explains a whole lot of things for me, individual level as well as in my research. Coming to Pune maternal nutrition study, it is actually based on some such evidences we had, so that we decided to study the determinants of fetal growth and body composition in Indians, and then said prospectively we will define the life course evolution of phenotypes, particularly diabetes. So in 1993, we went to 6 villages near Pune, documented by house-to-house survey, more than 2,500 women who were married but not pregnant. They were followed every month for their menstrual date, and if they missed 2 periods, they were considered pregnant unless sort of proved otherwise, which was proved by ultrasound. We were able to study more than 800 such women in detail in pregnancy. We also studied fathers against all the resistance from David Barker because of my friend Andrew Hattersley in Exeter, who told me you cannot not study fathers. And that actually has given us very interesting information. 770 babies were born who were studied in great detail at birth for anthropometry. Then every 6 months for 18 years to document their growth. And then every 6 years we have studied the family, that's the child and both the parents, for a range of phenotypes. And we have very impressive follow-up rates of more than 90%. It was reduced during COVID, but we have now picked up so that we again have more than 90% follow-up rates for our 24-year follow-up. Interestingly now, more than 200 of the girls born in the cohort have themselves married, had pregnancy, and they have their children. So the third generation has been born in this cohort. And we have an impressive biobank, which allows us to set up various measurements in relation to new factors which might be described in future. The mother in the study was on average 42 kg with a BMI of 18.1, so quite considerably undernourished. Babies were born 2.7 kg for 47 centimeter, which is 800 grams lighter and 4 centimeters shorter than an average European baby. 50% small for gestational age. Mothers were predominantly vegetarian, ate less of energy and protein, lot of carbohydrate diet, less micronutrient intake, lot of physical activity as you can see. And during that time, we did glucose tolerance test of these mothers and found less than 1% to be GDM by the then prevalent criteria. But 2/3 were B12 deficient, 2/3 were iron deficient, folate deficiency was relatively rare. And the babies, as I told you, were born about 800 grams lighter than this baby born in England. Because of my obsession with body composition, we measured 8 different anthropometric measurements and were able to find that actually this Indian small thin looking baby had more subscapular fat for each kilogram weight compared to the English baby. So Indian babies were thin, but they were fat. Original description in adults, but now we know it originates intrauterine. People, of course, don't believe simple measurements, so we had to do MRI on 30 babies in India and England, and that confirmed that all 3 abdominal layers of fat were higher in the Indian babies. Red cell folate was strongly related to size of the baby, and higher homocysteine, which is a measure of disturbed 1-carbon metabolism, largely happening due to B12 deficiency in this population, was a strong predictor of intrauterine growth restriction. So disturbed 1-carbon metabolism associated with smaller baby. These children, as I said, have been followed up, have had serial glucose measurements, glucose tolerance tests. At 18 years, they were on average 19 kg per meter square, so quite thin. But 30% of them had pre-diabetes by the American Diabetic Association criteria. 40% in boys, 20% in girls. Of these pre-diabetic boys and girls, 1/3 boys and 2/3 girls were actually underweight at a BMI less than 18.5. So very high prevalence of glucose intolerance despite very low BMI. How was it related to their past life? Those who had pre-diabetes at 18 years were born short. They had a smaller head circumference at birth. Mother who was not overweight or obese. And by ultrasound, we had measured intrauterine liver and kidney growth of the babies. And to my great surprise and joy, we could find that slower liver growth in utero was a strong risk factor for glucose intolerance in later life. At the same time, as I said, double malnutrition seems to be operative. Maternal glucose, which was normal by the cut point sort of criteria, was associated with prediabetes tendency such that higher glucose in the normal range predicted prediabetes in the child. Paternal glucose predicted higher glucose in daughter. Rashmi is sitting here and she has taught me about parent of origin effect. So we have some interesting things here. We are studying the genetics of this. Adiposity in male around puberty and larger liver at 18 years. This was not fatty liver on ultrasound, so I think we are describing a stage even before the fatty liver stage. This liver story is quite interesting, that's why I'm showing you this, that slower liver growth in utero was associated with different aspects of glucose metabolism, and larger liver at 18 years of age was related to a range of components of metabolic syndrome, including the molecule about which we heard yesterday quite a bit. They had lower adiponectin concentrations, despite, higher leptin and lower adiponectin. The intrauterine liver growth was, I divided into three groups, three tertiles. Those who had the highest rate of growth had the lowest prediabetes. Those who had the least growth were 4 times more likely to have prediabetes compared to the faster liver growth. And if you combine their liver size in utero and later life, those who had slowest liver growth but largest liver at 18 years were likely to be prediabetes 55% risk. That's massive. So if you have a poor intrauterine growth but subsequent overgrowth of organs, in this case liver, it could be actually confounded by pancreatic growth, but a very massive increase in the risk of diabetes in future. And that it was specific was shown by lack of association with kidney growth in utero. So liver specific for diabetes. Again, next year if you invite me, I'll tell you about kidneys and hypertension. So multiple organ concept put out by Allen and also by Ralph DiFronzo actually fits in very nicely with the intrauterine story. We have followed the glucose, as I said, along the life course of these children. And now I am talking about girls who have gone on to become pregnant during our follow-up. So this is their pregnancy glucose. And these girls who are in the highest quartile of fasting glucose at pregnancy are shown in red and lower 3 quartiles in blue. Those who had higher glucose in pregnancy had higher glucose at 18 years, at 12 years, at 6 years. And they continue to have higher glucose after delivery. In other words, we are looking at tracking of glucose from very early childhood into young adult age, into pregnancy and even post-pregnancy. And if you calculate the odds ratios or risk of having higher glucose in pregnancy, then it's significant for glucose at 6, 12, and 18, and common effect model shows 2.2 times higher risk. If we look at glucose intolerance at 24 years, it's even more, 5.2 times higher. In other words, it's all happening in the background from before pregnancy, but we call it gestational diabetes. And this is their glucose insulin metabolism plotted from 6 years into pregnancy and into later life, beautifully showing that it's the lower insulin secretion which is driving higher glucose, the so-called disposition index. Am I the first one to say this? Yes, we are the first one to say it in a cohort with such follow-up. But this has been said in literature by many people who had data on women before pregnancy, either because of design of the study, that's Pat Catalano's famous studies, in cohorts in US where they had one measurement before pregnancy, cohort in Australia, and the opportunistic reports from systems which have electronic health records like Kaiser Permanente in the US, Canada, and Korea. This has been said many times before, that women whom we call gestational diabetes already had higher glucose, higher BMI, bad lipids, family history of diabetes much before we diagnosed them as GDM. So the Dohed model of GDM which I would like to propose is that it is not gestational. We really don't know what defines diabetes in pregnancy. Yesterday we heard 8 different criteria for diagnosis. So we really don't know what's diabetes in pregnancy. Many definitions are based on pregnancy outcomes, some are based on without any outcomes. The short-term pregnancy outcomes are heavily confounded by the age of the mother, BMI, BP, lipids, etc. But we are glucocentric as diabetologists and we ascribe everything to glucose. To me, the real issue is programming of diabesity in the offspring. And that is genetic and epigenetic. And as I have shown you, it begins before the beginning of pregnancy. And I think that's a very important lesson I have learned. Yesterday we heard 2 orations on GDM. And to me, early GDM is, early you can diagnose it early or late. It has already happened before. So we should not create more confusions and saying that we have defined a new entity. I had written this editorial 15 years ago in Diabetes Care where I said, it's no use closing the stable door after the horse is bolted. And I think GDM is a story of trying to close the door after the horse is bolted for the Dohed intergenerational programming. So what other modifiable maternal factors we found? At 6 years, we found low maternal B12 in pregnancy coupled with high folate actually predicted higher adiposity and insulin resistance in the child. That's diabesity. Low maternal B12, high folate. Why should we have it? India is predominantly a vegetarian country. We have been vegetarian since days of Samrat Ashok, which is 2,500 years. 3 religions very strongly support vegetarianism. And interestingly, in a Pune study, we found higher education, higher income, and better hygiene predispose you to B12 deficiency. Very interesting, very counterintuitive. Why? Because B12 in nature is made only by microbes. So we acquire all our B12 in nature from microbes, and all our attempts to kill microbes around us might predispose you to B12 deficiency. On the other hand, vegetarian diet gives you folate, national programs provide you iron and folate, and to prevent the neural tube defects, obstetricians prescribe a lot of folic acid. So we have natural as well as iatrogenic situation causing low B12, high folate, and this affects the 1-carbon metabolism, which in turn is responsible for nucleic acid synthesis, repair, methylation, whole lot of basic processes in life, and that's a very important central mechanism. The programming which I have been talking about, periconceptional, has been again described for 1-carbon metabolism by a strong group in Europe, starting with Regine Stigers in Holland. And what they have shown is that there is a serial demethylation and methylation from the spermatozoa and the oogonia, then in the fertilized ovum, and this is finished within 48 to 96 hours of conception. And that's the window we are trying to tackle. This importance was described by British embryologist Louis Wolpert, who said it's not birth, marriage or death, but gastrulation, which is truly the most important time in your life. So that's much before we knew anything. And more evidence has come. I'm not going to go into details, this is my passion. But now a lot of experiments in humans and in animals have shown that maternal inheritance of glucose intolerance is actually through the insufficiency of enzyme which demethylates DNA. And that actually exposes the genes which, like say GCK here, which if it's hypomethylated, then it goes hypomethylated and causes the phenotype. We have measured miRNAs in the blood samples we have in the biobank and shown that those who were pre-diabetes at 18 years have abnormal miRNA profiles as early as 6 years, 12 years, and 17 years of age. Again, you learned miRNAs are part of epigenetic mechanisms. So we have very good proof for that. So based on this, we did a trial called PRIA, Pune Rural Intervention in Young Adolescents, when the children in our cohort were adolescents. Based on our B12 folate finding, we decided to supplement B12 and other micronutrients to these young people before they were married, before they were pregnant. And we followed them up for 8.5 years so that the second generation is born. And what do we find? Between the first two generations, that's the mothers whose picture I showed you, F0, and their daughters, in one generation in India, daughters are 6 centimeters taller than the mother. She is 6 kilograms heavier than the mother. Amazingly, she has 0.5 millimole higher fasting glucose and 1.7 millimoles higher 2-hour glucose during GTT in pregnancy. This is the only study in the world where mother and daughter had a glucose tolerance test at 28 weeks of gestation in the same study. So I am able to talk about it with confidence, yeah. So that's quite amazing. And we have supplemented them with micronutrients so that they have higher B12, higher folate, and lower homocysteine. So a lot of background development over 30 years, which gives girls bigger size or daughters bigger size, also accompanied by higher glucose and lipids, but better micronutrient situation. And what does it reflect in the babies? Again, the only study in the world where the babies, that's mother as a baby, and her children are measured in the same study. So the babies in the F2 generation were 200 grams heavier, they were longer, they had larger abdominal circumference, so probably bigger organs inside, larger head circumference, but very interestingly, despite such higher glucose in the mother, this baby doesn't have higher adiposity. And I think that is the success of my PRIA trial, that improving their micronutrient nutrition has avoided extra adiposity at birth, though it has allowed development of all of the organs. And this is, I think, a very welcome news for India, that if we do right things before the beginning, we are likely to curtail the epidemic of diabetes. We have followed up these children for their brain development, and we have strong evidence that B12 supplementation improved the brain function of these babies. We have defined molecular mechanisms, no time for that, but important to tell you that transcriptome in the cord blood showed that micronutrient supplement have reset the cell cycle. Such a basic mechanism, and we can demonstrate it in the cord blood after micronutrient supplementation. So the take-home message from my talk would be, think life course. There is a double burden of malnutrition, so you have to be aware of what to do. For India, don't forget to write B12 when your pen writes folic acid. And obstetricians do this routinely, that they write large dose of folic acid without B12. Better to prevent rather than treat. Primordial approach, which is before the beginning, is the best approach. It will be community rather than clinic. So we might go out of business. But that would be good for the country, that if we are able to prevent patients ending up in the clinic. And it will be art rather than science. So young people and non-medical people need to think how to execute such models or implement these in the community. Oscar Wilde said that I am a dreamer. For a dreamer is one, who can only find his way by moonlight. And his punishment is that he sees the dawn before the rest of the world. And I think that's what Doe had given. Thank you. Okay.
As a mark of our deepest respect and appreciation for the remarkable achievements and invaluable insight, may I now invite everyone to rise and join me in offering a standing ovation to honor Professor Yajnik. Thank you very much, sir.